So we are on section 5.1, systems of linear equations in two variables. Okay, guys, you'll remember what, guys, all a system is, well, in this section, we're talking about linear equations. So we have two equations. They won't be solved for y, and we're trying to find their intersection. That's what it means to solve a system. Typically, when you did this in some kind of high school course, you started off with graphing systems of equations. You would graph the lines on a calculator. You would find their intersection point. You list that ordered pair, okay? So that is that's the solution to the system. Then we go on with, okay, that's what it looks like graphically, but you got to be able to do it without, because sometimes graphically they don't line up at exact ordered pairs. Like they won't always be at like 2, 3 or 5, 7. Okay, it's going to be like square root of 2, 3. Okay, so you got that irrational number there, and they want exact solutions, so we learn to solve them using what we call substitution or elimination. And then section 5.2 is solving systems with 3 linear equations. So instead of just having x and y to solve for, then we have x, y, and z. So they go hand in hand of teaching them together. Even if we're not behind, I still teach them together because they all kind of flow together, okay? So example 1, it starts off pretty nice. It says, consider the system 2x minus 3y equals negative 4, and 2x plus y equals 4. So that's what we have. We have two equations like that. I'm going to go ahead and show you what those look like as far as in Desmos, okay, just so you can understand graphically what we're talking about. When we talk about a system, 2x minus 3y equals negative 4. And if you guys have didn't use Desmos, and you didn't probably use the full version in high school, if you did use the full version, you know you don't even have to solve for y. Okay, so this is the system. These are the two equations, and this particular question is asking us which ordered pair is a solution to the system. Now, you notice here with these two lines, there's only one intersection, right? Okay, and you can actually just click on there, and Desmos will tell you that intersection is at 1, 2. Okay, this is what the whole section's over. There's two lines, they're graphed. Do they intersect? Number 1, if they do intersect, do they intersect in 1 point or infinitely many points? And can you tell me where it's at if it's 1 point? Okay, that's all this is. Okay, so we start off, they give us two linear equations, and they say determine if each ordered pair is a solution of the system, okay? And we have A, the ordered pair 1, 2. Of course, we've looked at the graph. We do know that's going to work. And B, we have 7, 6. And we should know, because we looked at the graph, that 7, 6 is not going to work. It only had one intersection at 1, 2. Okay, so the way we have to prove this, though, all right? So all we're doing, guys, is we're substituting it back into each equation, and it should work. If it doesn't work, then it's not a solution. That point, 1, 2, has to be true in each equation. So I start off with the first one. 2x minus 3y equals negative 4. And so I've got 2 times 1 minus 3 times 2 is supposed to equal negative 4. That gives me 2 minus 6 equals negative 4, and that is true. Okay, so we're good to go with that one. We got one check mark. All right, that's good. Let's put it in the second one now. I've got 2x plus y equals 4. And so I'm going to have 2 times 1 plus 2 is supposed to equal 4. Okay, that gives me 2 plus 2 equals 4. And sure enough, that is correct. So it works in the second one. So this is a solution to the system. Yes. Okay, it is a solution to the system. Now let's try out 7, 6. So do the same thing over again. Guys, it has to work in both of them. 2x minus 3y equals negative 4. 2 times 7 minus 3 times 6 is supposed to equal negative 4. I get 14 minus 18. Does that equal negative 4? Yep, sure does. First one works. Okay, let's try it in the second one. 2x plus y equals 4. So 2 times 7 plus 6 is supposed to equal 4. Most of you can see from this point that it's not going to work. 14 plus 6 equals 4. That is not true, right? We get 20 equals 4. So it's not true. So this is a no. Okay. Your first couple of questions on your homework are like that. All you're doing is plugging in, seeing if it's a solution or not. Okay. Let's look at example 2. Example 2 says, solve by the substitution method. Now, I will tell you, at the end of the day, it doesn't matter how you solve it, okay? Whether you use substitution or you use what they call the addition method. Usually the addition method is called the elimination method, okay? This book just happens to call it addition. It doesn't matter, at the end of the day, you're going to get the same answer. And they'll have questions that say specifically to use substitution or use addition, and then it'll say solve however you think is best. Guys, honestly, if it's easier for you to do addition/elimination versus substitution, you can use that every time. What is your calculator? What is your homework grading? It's grading the solution, right? Unless it's a step-by-step process, and then, of course, if it's a step-by-step setup problem, you got to do it the way they tell you to. So they give us 3x plus 2y equals 4, and 2x plus y equals 1. And guys, when it says to solve by substitution, we're looking for the intersection of the two lines, okay? We are looking for the intersection of the two lines. Okay, that's what we're doing. Now, since we're doing this by substitution, when we solve by substitution, we need to get one of the variables by itself. So, for one of the equations, get one of the variables on one side by itself. Okay? Guys, the easiest way to think of that is when you were a lot younger, probably about the 8th grade is when you do it, you started solving for y. And they told you in order to graph this, it was either 8th grade or 9th grade, and when you took Algebra 1, they went, we want to solve for y. And honestly, they teach this in regular 8th grade math too. So you had to get y by itself, so then you could pick out the slope and you could pick out the y-intercept. You could plot that point and then go up, over, down, around, that kind of thing, okay? It comes from the same principle. So you pick whichever one you think is going to be easiest to solve for either x or for y. So when I look at this, I go, well, I'm thinking this second one is going to be the easiest one to solve for y, okay? Because y is by itself. There's no coefficient in front of it, right? So I'm not going to have any fractions. I'm not going to have to divide anything over. He's positive where he's at. All I've got to do is move that 2x over to the other side, right? It's a simple one movement solve, okay? So I'm going to take my 2x plus y equals 1, and I'm going to subtract that 2x, okay? I get y equals negative 2x plus 1. All right, we're going to use him again in a minute, okay? Now, substitution works like once you have solved for one variable, substitute that back into the other equation. Okay? So for us, that's the top one, the one I haven't highlighted. So I'm going to take y equals negative 2x plus 1, and I'm going to plug him into the 3x plus 2y equals 4. Okay? So I've got the equation I didn't work with. Equation I made no changes. Okay, so that's 3x plus 2y equals 4. Now, what I'm going to do is I'm going to take that y equals negative 2x plus 1. I know what y equals, and I'm going to plug it into that first equation. Plug in negative 2x plus 1 for y. Okay, so this is going to become 3x plus 2 times negative 2x plus 1 equals 4. Okay? Notice, y equals negative 2x plus 1. Where I saw a y, right here, I put in negative 2x plus 1. That's all I did. Now, that equation is just x. Right? It only has x in it. I can solve for x. I can get half my answer. I can solve for x there. So I'm going to distribute that 2 in the front, so that gives me 3x minus 4x plus 2 equals 4. That's going to give me negative x plus 2 equals 4. I get negative x equals 2, which means x equals negative 2. Okay? So we plugged in, solve for the remaining variable. That's what we did right there. We got x equals negative 2. Now plug that value back into one of the original equations. Okay? So it doesn't matter. Okay, so we have, I'll put that in blue. And so here we go. We're going to plug back into an original. Okay, I'm going to plug him back into the second one, and let me tell you why. Because it's going to be easiest to solve for y. because y doesn't have a coefficient in front of him, so there's not going to be any dividing for you guys. I'm literally going to plug in -2 for x, and then I'm going to add him over. Okay? So I take 2x plus y equals 1. I'm going to plug that -2 in for x, so 2 times -2 plus y equals 1. That's going to give me -4 plus y equals 1. And that'll give me y equals 5. Okay? Let's write that as an ordered pair. That should be -2, 5. Now, you can check that just like we worked example 1 by plugging it back into both of them and making sure it works. I'm going to put the original equations in Desmos, and we'll see if they intersect at -2, 5. It should be a little quicker than actually having to plug it in. Let's see, I've got 3x plus 2y equals 4, correct? Is that what we had for the first equation? And is the second one 2x plus y equals 1? Okay, if I click right there, I get -2, 5. Is that what we got for our solution? Yeah. Go. Okay. So you can check yourself when the answers are nice like that. Okay. Let's look at example 3. Okay, this time we're going to solve by the addition method. Okay, and I have 4x plus 5y equals 3, and 2x minus 3y equals 7. Sometimes this is called elimination method. If you take any other math classes, they're probably going to call it elimination, depending on how old the authors are that wrote the book. Okay? Okay, so when we use addition method, our goal, what you need to do, your goal is to get either the coefficient of the x's to be opposites, so like a +4 and a -4, or the coefficients of the y's here to be opposites, like everybody would need to be like a +5 and a -5, or a +3 and a -3, or some multiple of that, okay? So we want the coefficients of one of the variables to be opposites. Okay, and so y'all are going, well, nobody is. One's a 4, one's a 2, one's a 5, one's a -3. I can't do anything with this. You can. What do we do sometimes? Sometimes I'm over here like, oh, we're just going to multiply it times 1 over x plus 2. And y'all are looking at me like, we can't do something like that. And I'm like, yeah, we can, as long as we do that on both sides, right? It's got to be fair. You got siblings, mama gives one of them, that baby one something, you best be getting something too, right? Yes, that's how it works. As long as we do the same thing to one side that we do to the other, it's okay. So, for me, I pick that I want to add or eliminate those x's because 4 is a multiple of 2, right? Okay, so I just need to somehow turn that 2 on that 2x into a -4x. Well, how can I do that? What can I multiply by to make that positive 2x turn into a -4x? 2 times what gives me -4? -2. So I'm just going to take this right here, and yeah, I write on the problem, and I go, okay, I'm going to multiply him times negative 2. So here's what I have. I write down my first equation just like he is, 4x plus 5y equals 3. Now, I'm going to multiply that entire second equation times negative 2. That's going to give me negative 4x plus 6y equals negative 14. Now, here's where they get the word, this is the addition method. They used to call it elimination method because what am I doing? I'm eliminating the x values here, okay? So once we have the coefficients of the one of the variables being opposite, okay, I need to add them together, okay? Once the coefficients of one of the variables are opposites, add the equations together. Okay? All right, so I'm going to add them together. What does positive 4x plus a negative 4x give me? 0. So I don't even have to worry about writing anything down. 5y plus 6y is 11y, right? Equals, this one's friendly, what's 3 plus negative 14? Or 3 minus 14? Negative 11. Yeah, negative 11. Now, you got one variable left, so we can solve for it. So I'm going to divide both sides by 11, and I get y equals negative 1. Okay, that's going to be important. Okay, so what did we do? We solved, or we just say we're going to solve for the remaining variable. Okay, we did that. Now, substitute the known value back into an original equation. Okay? So you're going to plug it back into one of the originals. Okay? Not the one, you could put it back in the one where you'd multiplied by the negative 2, but it's easier if we just go put it back in one of the originals. Okay? So it doesn't really matter which one. I'm just going to put it back in the first one, okay? They're both about the same amount of work. So I've got 4x plus 5y equals 3. That's going to be 4x plus 5 times negative 1 equals 3. So 4x minus 5 equals 3. Add that 5 over. I get 4x equals 8. I get x equals 2. Okay? Solve for the last variable. Okay? So we've got y equals negative 1, x equals 2. When I write that as an ordered pair, that becomes 2, comma, negative 1. Okay? I'm going to go over here and check it. Okay, I've got 4x plus 5y equals 3. Oh my. 4x plus 5y equals 3. We'll try that again. And then I've got 2x minus 3y equals 7. Okay, so I'm going to have to do a little move in here. That's the cool thing about Desmos. You don't have to set a window. You can just move around. You get the point 2, negative 1. Was that the answer we got? Okay. And we're good to go. All right, let's look at example 4. Example 4 says, solve by the addition method. Okay. I have 2x equals 9 plus 3y, and 4y equals 8 minus 3x. Okay, well, this one's kind of a mess, isn't he? And I'm going to tell you the addition method is the easiest way here. Here's how I know. Even though each one is almost solved for just x or just y, where we could use substitution, think about if you solved for x on that first one, I'd need to divide by 2. And if I go dividing by 2 in that first one, I'm going to have myself a fraction of 9 over 2. And when you guys go plugging that back in, it don't turn out real well, does it? No. It makes things a little messy. So, but you're going, well, using addition method, things are all messed up here, right? Well, they are, but you can move them back over. So we need to turn this into an ax plus by equals c for both of them, okay? So I've got 2x equals 9 plus 3y. Well, what do I need to do? I need to move that 3y over to the left. So I'm going to subtract 3y from both sides. And that's going to give me 2x minus 3y equals 9. Okay, he looks good. Then over here on my 4y equals 8 minus 3x, I know I need to move that 3x over. So I'm going to add 3x to both sides. And that's going to give me 3x plus 4y equals 8. Okay, so now I really have 2x minus 3y equals 9 and 3x plus 4y equals 8. Okay, so this is what we're working with when we're trying to use the addition method, right there. So I've got them lined up. I've got the x's lined up, got the y's lined up, and then my constants are over there. Now, looking at this, it's not as nice as it was in example 3, where one of them was already a multiple of the other one. 4 was a multiple of 2. All I had to do was multiply that bottom equation by -2. That's not the case here. We've got 2 and 3. We've got 3 and 4. Okay, so what we're going to have to do, no matter which one we pick to add together and eliminate, we're going to have to multiply both equations by something. Okay? For me, it's easier to get rid of the y's here, because right now those y's already have opposite signs. So I don't have to worry about multiplying anybody by a negative, which means I don't have to worry about missing a negative somewhere. Okay? So I want 3 and 4 to become what? I want to get rid of those y's. 12. Good. So I'm going to multiply that top equation times 4, because I want to turn that -3 into a -12. And I'm going to multiply that bottom equation times 3. And here's the deal, guys. If you don't know a smaller value, in this case, there wasn't a smaller value. 12 was the smallest one. But if there could have been, like, if you're not sure what it's going to be, you can always, if you're having to multiply by something, you can multiply. Notice how 4, we multiplied by 4, and that was on 4y. And then we multiplied by 3, and that was up here on the -3y. You can multiply them by the opposite of each other, the other one, and you will get, they'll cancel out, okay? Because you're multiplying them together. All right, so this is going to give me 8x minus, maybe you want me to write it over there. That's going to give me 8x minus 12y equals 36, and then I get 9x plus 12y equals 24. Okay, now it looks lots better. We're ready to add them together. Well, the 8 and the 9 give me 17x, right? Those y's are going to go away. They zero out. Equals 36 and 24 are going to give me what, 60? So this one's not as nice, is it? I'm going to divide both sides by 17. And will 60 over 17 reduce? I would say no. 17 is prime, correct? The only thing that goes into 17 are 1 and 17. And 60 is not a multiple of 17. So that's as good as it gets, and you can leave him as 60 over 17. Okay? And so we've got our 60, oh, don't box him, I'm sorry. We've got our 60 over 17. Now we need to take that and put it back into one of the originals. Guys, since you know x, I would probably put it back into that second one because you've already got it set up where y is on one side by itself, okay? So I'm going to take 4y equals 8 minus 3x, and I'm going to put that 60 over 17 in there. That gives me 4y equals 8 minus 3 over 60 over 17. You do have a calculator, guys, that you can use. Somebody remind me in just a second what that says. 8 minus 3 times 60 over 17. This is your little calculator here. Let me go to mode. I need math print. Okay. So I've got, somebody tell me what it says.
8 minus 3 times 60 over 17.
Thank you. Because I didn't remember any of it. Okay, like that. That's what we got. And that's going to give me negative 44 over 17. Okay. So I'm getting negative 44 over 17. I'm going to divide both sides by 4. Guys, you can do a stack on a stack in your calculator, in your multi-view. Make use of it, okay? This is going to give me, okay, I've got negative 44 over 17 all over 4. So I have negative 44 over 17 all over 4, right? That's going to wind up being negative 11 over 17 is what it should be. Yeah. And I get negative 11 over 17. Okay. So I am getting the ordered pair 60 over 17 with negative 11 over 17. Now that one does look a little nasty, doesn't it? So let's check him. Let's make sure. This was example 4. I had 2x equals 9 plus 3y, 4y equals 8 minus 3x. Okay. And I'm going to go over here to Desmos. We'll probably have to do a little bit of extra work there because it's going to give me a decimal. Equals 9 plus 3y. And then I've got 4y equals 8 minus 3x, correct? Okay, what did we get? What was our x value? 60 over 17? 60 divided by 17. Not 6. Go up, go up, go up. Go up. Oh my God. 60 over 17. Okay, so 3.529. And then what was my y value? Negative 11 over 17. Let's see if I can actually, okay. So let's see if that's what we get here. So we see that, yep, that's exactly what we get. Let's see if we can actually make that turn into, nope, we can't make him turn into a fraction. Sorry, guys. So we get they are giving us in decimal format the answer, which was 3.52941 with negative 0.64706. And sure enough, when we put in our fractions of 60 over 17 and negative 11 over 17, those are those decimal approximations. On your homework, they will want them in fraction form because that is the exact value or the exact answer, whereas if you're putting a decimal in, you're giving an approximation. And that was the point of them making you do it by the addition method instead of having you graph it, is so that you could give the exact answer. Okay? So they want the fractions. All right, that was example 4. Okay, little notes for the day. Not much there, right? The number of solutions to a system of 2 linear equations. Okay, so it's a little table. Here are the number of solutions that we can have. So I can have one ordered pair, which that's what we've seen, right? I can have no solution, which we've not seen yet, but we're fixing to, of course. Or I can have what we call infinitely many solutions. Okay, now this is what produces it pretty much. And it's called what this means graphically, because we've been looking at the lines, right? We've been looking at those graphs and seeing if our points were correct. So that gets the concept over that it's the intersection of those two lines. Well, one ordered pair, we've noticed if we get an answer of one ordered pair, it's 2 lines intersect at 1 point. Okay? If there's no solution, guys, you still have 2 lines, but it's no solution, so there's no intersection. What kind of lines never intersect? Parallel. Good. So no solution is the 2 lines are parallel. Okay? And if we have infinitely many solutions, guys, it's honestly the same line. Like, it won't look the same, like the equations won't look the same, but one will pretty much be just a multiple of the other, okay? So we say, because what happens is you've got one line, then you've got another form of that line, and we're saying it lays right on top of the line, so it has infinitely many solutions because it is that line. Okay, the 2 lines are identical. Okay. All right, so let's look at, we do have example 5 and 6 still on 5.1. Because we need to look at when they're parallel, and we need to look at when they're the same line. Okay? Example 5 says solve the system. Okay? Now, it doesn't tell you that you have to do it by substitution. It doesn't tell you that you have to do it by addition. It just says solve the system. And I have 5x minus 2y equals 4. And I have negative 10x plus 4y equals 7. Okay, now, and like I said, it's just me personally. I rarely use substitution. The only time I use substitution, if there's an x by itself already with no coefficient, and there's a y with no coefficient. That's the only time I go to the trouble of using substitution. It's just always easier for me personally to use addition/elimination. So for me, I would go, you can eliminate either one that you want to. I personally look at the 2 and the 4 and I go, I want to eliminate the y's because I can change that -2 into a -4 very easily, right? So I'm going to multiply that first equation times 2. That's going to give me 10x minus 4y equals 8. And then I've got -10x plus 4y equals 7. I don't do anything to the second one. All right, so I got those y's the same. I'm ready to do some elimination or some addition there. Well, when I go to add them and I say 10x plus the -10x or 10x minus 10x, well, what's that? That's 0, right? That wasn't what I was trying to get rid of, but okay. Well, then what's -4y plus 4y? 0, right? Equals, what's 8 and 7? 15. So I'm getting 0 equals 15. Well, is that ever possible? Nope, not possible. So this is no solution, which that means these lines should be parallel, right? We can write that little note. Not lines should be parallel. Okay, let's go look. I've got 5x minus 2y equals 4. And then I have -10x plus 4y equals 7. And sure enough, I have a set of parallel lines. Okay? So, no solution. All right, let's look at example 6. We want to solve the system. Of course, you know, since we've talked about the intersection of one intersection, we've talked about no solution. This one's going to be in infinitely many. That's the last one left. It's the last example. Solve the system. Probably one of the reasons I like math most of the times. It's predictable. Even the textbook. X equals 4y minus 8. And then we have 5x minus 20y equals -40. Okay? Let me highlight. I'm going to highlight this. And you'll see why I highlighted it in a minute. Okay, now, when I look at this one, I go, I'm using substitution here because they've already got it set up for me, right? They already have one variable by itself on one side equaling some other stuff. So I can literally take this, substitute it in to the second one, right? So I'm going to take 5x minus 20y equals -40, and I'm going to substitute in that 4y minus 8. So this becomes 5 times 4y minus 8. And guys, I got all this from this is that. Okay? 5 times 4y minus 8 minus 20y equals -40. Okay? 5 times 4y, now distribute the 5, so that's 20y. And then 5 times the -8 is minus 40, minus 20y equals -40. Well, I go to combine like terms on that 20y and negative 20y, and what happens to them? They make 0, right? And I'm left with negative 40 equals negative 40. Well, is that true? Yes, this is true. It's always true. Okay, that's not ever going to change. You can't do anything that's going to change it. You add 1 to the right-hand side, you got to add 1 to the left-hand side, or subtract. They're going to always be the same, okay? So when we get something that's true, up here we got 0 equals 15. That was false, right? That was false. He was not possible. It's not possible. Negative 40 equals negative 40. That's true. So when we get a true like that, we go infinitely many solutions. So what we should be seeing is one line on top of another one. It's the exact same line when we go to graph it. Okay? So I'm going to go over here and I'm going to put in x equals 4y minus 8. And it'll take me just a second because we'll have to turn the colors on and off. X equals 4y minus 8. Okay, he's in blue. And then, not a very bright blue, so I don't know if he looks blue on the screen for you guys. Equals negative 40. And he's supposed to, uh-oh, what happened? Did I put the wrong thing in? Oh, that's why. I'm like, them things are parallel. What the, there we go. Okay, sorry. Thank you. Negative 40. That means sometimes, maybe that means I'm not alive because, like, there's no heat coming out of my fingers to make the 0 happen. You know, because that's how a phone or a iPad work is by heat sensitivity. Never mind. It doesn't matter. Okay, moving on. Okay, so you're like, okay, well, there was a blue line, and then once you put that 0 in there, then there was a green line, and the blue line went away. Okay, so here's the deal, guys. Here's how it's the same line. There's the first one that's blue. Okay, then I turn the blue one off. I'm going to turn the green one back on, and he appears in the same place. Okay, if I turn the blue one back on, the green still overlays the blue because it's a darker color. Anyway, so it's the same line. So since they lay on top of one another, it's infinitely many solutions. Okay? And that is all of 5.1.